So the goal of this experiment was to determine the concentration of bisphenol A in canned foods through gas chromatography and mass spectrometry. We began by doing a derivatization and an extraction of BPA from the canned food sample. In this experiment, we used salsa, and we first generated a BPA stock, which was a 1 gram per liter BPA that was dissolved in a 1-to-1 mixture of water and acetonitrile. And then we extracted the BPA from the salsa, and we used a derivatizing agent to substitute these OH groups in the BPA for these ester groups. And this will allow it for the BPA to flow through the column instead of sticking to it like it would with these OH groups. So first we wanted to determine the ideal temperatures to run the experiment, and we tried three different variations of temperature. We tried the low temperature, which we started at 70 degrees Celsius, and we held it for 2 minutes, and then we ramped it up to 250 degrees at a 10 degrees per minute temperature change, and held at 250 for 30 minutes. The medium temperature, we started at 100 and held it for 10 minutes. That did the same ramp up of temperature that it explains here. And for the high temperature, we started at 150 degrees Celsius and then held it for 15 minutes. The temperature that we chose was a medium temperature. We realized that as the temperature got higher, the peak of the BPA used here, and we to obtain this chromatogram, we ran the standard BPA. And so the peak shown here would become much narrower as for medium and high temperature. So low temperature had a very wide peak, which is not what we wanted, and medium temperature was the condition that had the narrowest peak. So that's the one that we moved forward with. Next, we determined the ideal flow rate, which we again used the BPA standard, ran it through the column, and we obtained these chromatograms. This is using 3 different flow rates, and we found that as the flow rate increased, the BPA stayed in the column longer. That is, the retention time increased, and the peak became more narrow. So we created a Van Deventer plot, and this plot showed us that the 0.9 milliliter per minute is the flow rate that is ideal for this experiment because it has the lowest height, which means it has the highest amount of theoretical plates. So moving forward with these parameters, we then did a total ion chromatogram and a selected ion chromatogram. This is again using the BPA standard. And here it shows that the selected ion chromatogram is the way that, or what we chose to go forward with, because it only shows one peak. It's much cleaner. And in order to obtain this, we used 357 mass to charge selected ion. So we then did various standard addition with the BPA standard. So we obtained 5 vials, and we put 10 milliliters of unknown in each of the vials. And then in 4 of the vials, we added these corresponding standard constant or standard volumes. So we added 100, 200, 300, and 400, and one of the vials remained with just unknown. And this allowed us to create a linear fit to the data. And here we graph the area of the peak of the BPA that we obtained from the chromatogram. So here's the area versus the standard added in microliters. This allowed us to obtain this equation shown here, which we used to calculate the concentration of BPA. And in order to do this, we simply just found the x-intercept of the equation. And taking into account all dilutions, the BPA in the canned salsa was found to be 1.7 milligrams per gram with a uncertainty of 0.5.